Hi, Srivalli.
Hi, Shanti.
So, in today's session, we're going to see what is NumPy and how ML models are applied through NumPy and how these ML models can be migrated to Azure machine learning, and
Yeah.
later on how Azure ML can be migrated into generative AI services to save the cost of the project. Okay.
Hmm.
So, you are able to see my document, Word document.
Yeah, I'm able to see.
Okay, so first topic is utilizing NumPy for data analytics and machine learning in Azure Cloud Services.
Hmm.
First, let us see the introduction about the NumPy usage. While applying for Azure Cloud Services, NumPy can be used for various data processing and analysis tasks, especially in the context of machine learning, data science, and analytics. NumPy is a powerful library for numerical computing in Python and provides support for large multi-dimensional arrays and matrices, along with a collection of mathematical functions to operate on these arrays. If you see statistical analysis, there are advanced statistical analysis topics are there. ANOVA is there. Analysis of analysis of variance analysis. Basically, what happens is they take some samples and those they are going to analyze it and give the prediction results through the ANOVA analysis. Okay. The same way, this NumPy has got that kind of capabilities like statistical analysis tools also with mathematical functions. Okay. So
Hmm.
here are a few ways NumPy can be used when applying for Azure Cloud Services. Data processing.
Hmm.
NumPy can be utilized to pre-process and manipulate large data sets before they are uploaded into Azure Cloud Services. This can include tasks such as cleaning and transforming raw data, featuring engineering and data normalization. Here there are two topics I want to bring it up here. When you
Hmm.
say manipulate large data sets, you take weather forecasting. 20 years back, weather forecasting was totally different. 25 years back, around 95. In 98, when internet came, it improved a little bit. Then
Hmm.
after 2000, it accelerated the improvement. Now, in today, if you see, if any prediction is given for weather forecasting, it should come. For
Hmm.
example, I am in Bangalore. When I use my mobile, it appears for weather forecast also on the screen, on the desk. It is a kind of desktop screen. It shows
Hmm.
the temperature also. In the weather forecast, what time it is going to rain also it shows. It is
Hmm.
doing exactly with few minutes up and down.
Yeah.
It means what they have used to, they used the machine learning and data science methods by taking the past data, by taking the predictions. Okay,
Hmm.
so that kind of data sets are useful to use it for analysis purpose. That way the cloud services are being used extensively because data storage, it is a huge raw data. Okay, then
Hmm.
another thing is you take a data warehouse project. I told you, if you take any e-commerce stores, whether
Yeah.
Circuit City or Best Buy, electronic items.
Hmm.
Uh, they might have got customers incrementally since 20 years. Every year they're coming and buying some equipments.
Hmm.
Okay, audio video equipments. Okay, now they need to see the past data also. How this customers richness is there since 20 years. Let us say that is the question asked by one business analyst. Okay. Now, what the business analyst need to know? He need to get the raw data from mainframes, basically,
Hmm.
because 15, 20 years back, they used the legacy applications with character user interface before 20. More,
Hmm.
the mainframe applications. And in DB2, kicks, screens, they used all the data. That need to be processed. But that time, they did not fill all the fields. They were not aware what are the mandatory fields, non-mandatory fields also when they designed that COBOL systems. Okay,
Mhm.
many of them they kept it idle. If user fills it, it will have the data. If user did not fill it, it will not have the data. Now, how are you going to transform the data? With cleaning process. That cleaning process is available in Azure, and it transforms the data. Here, if you see, there is a topic called in data warehouse ETL. E stands for extraction, stands for transformation, L stands for loading. So in the phase of E, it extracts from mainframes into some
Mhm.
formats, data
Yeah.
forms. Then after that, it is going to work with some programs. It can be Perl program, it can be Python program, it can be PLSQL program, or anything that is going to be used for transforming the data. When it is transforming the data, before going for transformation of program input, the data need
Mhm.
to be cleansed. What are the ways they are going to clean it? Let us say male, female need to be identified. It. Some of
Mhm.
the fields are blank. They'll assess it and they'll fill the data.
Okay.
Then some fields are not there. They can pad the data. Okay, because all fields need to have complete data to process into analytics. Okay, that is
Okay.
the rule they have made it. Now, after that, it is going for extraction. After extraction, it is going for transformation. Then after that, it's going to load into the data marts. Okay, so
Mhm.
basically what happens, these all processes are inbuilt within the Azure cloud services with different services. Okay, like Databricks, it can be data lakes or whatever it is services. Feature engineering and data normalization will happen. How you are going to normalize the data? The same way you are taking the test mainframe data and putting them into different table formats. The tables are connected through the primary, secondary keys in relational database structure,
Mhm.
right? So that is the data warehouse project setup. They use it. So there they are doing a data processing also before doing ETL process. Next one is model development. How, how it is happening. NumPy arrays can be used to represent the input features and target variables for machine learning models. So here, what are the arrays? If you see C programming or C sharp program, there is a concept called arrays, dimensions or arrays in any programming language. With
Yeah.
arrays, you can do processing within the memory itself, with RAM itself. You
Yeah.
don't need hard disk, right? That memory is very faster to process it. So NumPy has got that kind of features to process the arrays with faster thing, and the input features the target variables for machine learning models. It means it has got its own structure for that
Yeah.
to receive into variable formats, arrays formats. Okay, NumPy's
Mhm.
array manipulation capabilities can be crucial for preparing the data before training machine learning models. We discussed several times. There are different models need to be trained. When you take that, you need to have
Mhm.
samples of the data. Then it digests that formula, that algorithm. Then it can be transformed into particular model. This model is going to work for this one. That's the way
Mhm.
it is going to apply in the implementation. So, data before training machine learning models on Azure cloud based machine learning services. Basically, these models were implementing in Azure cloud based machine learning services. So, that is about model development with NumPy arrays also.
Mhm.
Okay. Data analysis and visualization, if you see, NumPy can be used in tandem with other Python visualization libraries to
Mhm.
analyze and visualize data before or after it has been moved to Azure. It
Mhm.
means if you take Python, Python is a vast tool, vast, I can say, either scripting language or something like that.
Mhm.
But it has got different libraries for different business functions.
Mhm.
So it can create the dashboards also with few code snippets.
Yeah.
The same way, NumPy also has got similarity with Python libraries. So where once it is moved the data into Azure with NumPy, you can display into the dashboards also. So data analysis and visualization. Visualization is connected with the dashboards.
Mhm.
This can involve tasks such as creating plots, statistical analysis, and exploratory data analysis. These all are the statistical methods using tools, statistical analysis tools. The same analysis is being applied in NumPy also.
Mm.
Okay, so when they used R programming also has got similar techniques and models they applied for machine learning 10 years,
Mm-hmm.
15 years back. R programming, if you see. Okay,
Yeah.
then later on, NumPy became very easy to use the libraries and simplify the logic and maintenance of that. Okay.
Mm-hmm.
Now, custom functions and optimization. NumPy allows for the creation of custom mathematical functions and operations, which can be integrated into custom machine learning models or data processing pipeline for Azure cloud services. It
Mm-hmm.
can be any kind of series of the mathematical formulas who can use it to process the data. When you see the statistical analysis process, there are sequential statistical formulas are there, like
Mm.
sigma kind of thing, and variance analysis. Okay, then
Mm-hmm.
ANOVA table creation. Then there are so many advanced statistics also. So
Mm-hmm.
all those can be applied with these things by customizing that models also. Let us say one time you want to do only simple statistical analysis. Yes, you have the
Mm-hmm.
NumPy program for that. You created that model, simple analysis. Then after that, ANOVA table is required.
Mm-hmm.
Then you are going to apply another script with that kind of analysis. It means that is nothing but you are having some data sets, you are pulling them and analyzing it and drawing some kind of output of that. Statistical analysis outputs. Okay, so which can be integrated to custom machine learning models or data processing pipelines for Azure cloud services. See, when you say integration, there are two concepts. You can build a fresh ML systems with Azure
Mm-hmm.
without having the past models.
Yeah.
Another thing is you can attach these NumPy libraries to the Azure machine learning models to work in the same fashion, in the same structure, without changing the functionality. Let us say, if you want to build with ML models, you need to understand the methods, the ML methods,
Mm-hmm.
what they want to use, the data scientists. They will give a sequence of the steps to use the models. Okay, then that is a fresh startup. But if you have already running system, running model, that model can be connected to the Azure ML services. You need
Mm-hmm.
to see these categories here. These are the real implementation practices when you integrate NumPy with Azure machine learning process.
Mm-hmm.
You got it?
Yeah.
Okay. Then these are the custom functions. Then these all about NumPy applications, how it can be built. It what are the ML techniques or tips we can use it to apply NumPy, and how it can be connected directly to the Azure cloud services also. Okay, it means here we are not yet discussed about the Azure machine learning models. We discussed about Azure cloud only, Azure cloud. Okay, up to that.
Mm-hmm.
Now we are going forward to use NumPy when applying for Azure cloud services. You can follow these general steps. One is data preparation. Use NumPy to read, pre-process, and manipulate data as needed before uploading it to Azure. Yes. So model development. Utilize NumPy for creating and formatting input data for machine learning models. We have discussed in the previous examples how these are applied it, as well as for implementing custom mathematical functions and of our operations. This is also discussed later. Integration with Azure services. Once the data is ready, you can upload it into Azure storage solutions. It means blobs. You know what is storage solutions in Azure? Blobs, right?
Mm-hmm.
Blob.
Yeah.
Azure Machine Learning Services or other relevant Azure Cloud Services. Yes, basically. You can use data lakes also. Data lakes also uses blobs. Okay, the same way.
Mm-hmm.
Data analysis and visualization. If needed, use NumPy along with other visualization libraries to analyze and visualize data stored on Azure. It means
Okay.
even though
Mm-hmm.
you
Mm-hmm.
uploaded the data into Azure,
Mhm.
You can visualize through NumPy libraries also by using
Oh, okay.
API method or external accessing method. There are so many tools with every cloud services. They
Mhm.
have integrated under API concept to display the data in cloud what is happening. There are so many monitoring tools. So monitoring
Okay.
tools brings the cloud services data, how they are functioning, what kind of issues are appearing, all those things are displayed through the tools. It means Azure, any cloud service has got APIs to connect as adapter to that particular tool. The same way NumPy
So,
also has got APIs.
one
Yeah.
question.
Tell-
So, we need to
Yeah.
go back a little bit. So, NumPy can be used for data pre-processing, right? So, for data
Hmm.
pre-processing, we can use data lakes and there's also data bricks. So,
Yes.
is this in
Yes.
addition to Databricks and data lakes that we use NumPy, or is it that NumPy library's purpose is different? What is the purpose of NumPy library in data preparation? What is its purpose? What is its role? Because we also have
Okay.
Databricks and
Oh,
data
hold on.
lakes.
Hold on.
Yeah.
Hold on. What is Databricks, from where it is coming?
Databricks is a Azure feature, Azure
Hmm.
functionality that you
Yeah,
can
Azure
use for
feature. Uh,
pipeline. Yeah.
yeah, right. What is the cost estimation for that? 1 month if you are using that?
That I'm not sure, but it's probably
Uh,
high.
yeah, right. NumPy is what? Is it a cloud or independent system?
Oh, it is a library. It is independent Python library.
Is there any cost involved for that? Only memory it
Hmm.
occupies.
It
Is there
occupies
any
memory
cost?
for processing. Yeah. No, there's
So what is the difference here? You tell me which one you are preferring to implement it for cost solution.
so I use so is it NumPy you use for processing the data, but still storing the data is using the blob.
You need a database server, right? Database server, obviously, which is the best one? Azure
Data
Cloud.
Azure Data Lake is the best.
No, 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 no. I'm saying database server. When you prepare the data, you
Yeah.
need to store into Azure, our Azure database.
Yes.
Okay. But processing purpose, you are using data lakes and data bricks. When you
Okay.
use those things, what happens? It is a service. You need to differentiate between the service, which is going to cost, which is library within the
Yeah.
hard disk. It is running the content. Okay,
Mhm.
but it is pulling the data from Azure database and processing and pushing it. What
Yeah.
are the use of the Azure arrays? You are copying that data into local memory using the arrays.
Mm.
You got the concept here, right? When I discussed
Yeah.
examples, NumPy
Yeah.
arrays.
Yeah.
So what it does, it while preparing the data, it copies into the local arrays. Then local arrays is
Oh.
nothing but your RAM.
Yeah. RAM. Yeah.
You use high-end GPUs in the virtual
Mm.
machines itself. You can process with NumPy. You don't need to use the service continuously, like Databricks or data lakes or anything. You can save the cost there in the project,
Yeah.
right? So
Yeah.
when you say data preparation and data processing, you have millions of data, millions of records.
Okay.
You don't know how many hours it takes. So that many hours, if you are using data bricks or data lakes services, obviously the cost is going to increase it. You are the economist for the cloud services also, not only a role playing like cloud solution designer or cloud solution expert. First thumb role in your mindset should come, which is the best way to give cost effective solution
Mm.
while giving the solution to the client.
Yeah.
You should not see like why should I not use Databricks or why should I not use data lake like you questioned just now. No, you should not think that way. You should think what is the cost effective solution when I am doing this kind of activity. Each activity you should justify yourself.
Mhm.
Okay, if NumPy libraries are running slowly, yes. If data lakes are doing faster or Databricks are doing faster, yes. If huge data is there, obviously you need to give justification that way, because we have millions of data to process that. through Databricks only it is possible. NumPy is a slow process. You have to justify. Depends on the scenario you need to justify. Today I can't tell what kind of project you are going to get it there in live and what kind of activity you are going to perform it there. Just you need to understand the features and practices to implement it. Depends on the situation. That's it.
Okay.
Am I correct?
Okay. Yeah.
Okay. Now let us do here one more time. We'll revisit. So what we covered here, data preparation with NumPy, model development, integration with Azure services also. It means whatever you process the data, you can upload it. Still data lakes or data bricks can be used for ETL processing. We are not saying we're not going to use data bricks, but we don't need to work for data preparation, data correction, all those things. With NumPy, you can do it very easily without cost. That activity or
Okay.
that task can be saved it, right? Then
Okay.
integration with Azure services we have seen. Now once the data is ready, you can upload into Azure storage solutions, Azure machine learning services or other relevant Azure cloud services, right? Then fourth one is data analysis and visualization. If needed, use NumPy along with other visualization libraries to analyze and visualize data stored on Azure. Okay. By leveraging NumPy's capabilities in data manipulation, analysis, and model development, you can enhance the effectiveness of your applications and solutions when working with Azure Cloud Services. When you say solutions, it is included costing solutions also. When you say you are the solution expert, first thumb rule the stakeholders are going to ask for cloud projects. What is the costing going to happen for this?
Yeah.
It should be there on your fingertips for each service. How many hours it takes, how long it can work for this service, what is the cost going to be, monthly cost. There are calculators with every cloud service online. You can estimate that and give a rough estimation for them. Then only they are going to approve your project. It's not simply you go and work like a software engineer in the cloud sector. That is the way it works in implementation of the cloud practices. Okay, right. So now that is the one how NumPy can be integrated with Azure Cloud. Now we're going to move forward with ML solutions, Azure ML solutions. So far we have seen up to applying NumPy libraries or process with Azure Cloud only. How you can use it? Simple cloud, Azure Cloud without ML options. Now, when NumPy-based machine learning models need to be converted into Azure machine learning, there are several options available to facilitate the migration process. Some of the common approaches includes, see here, we are supposed to do models migration into ML, Azure ML. It means we need to map those things to particular Azure ML services. That's where we're going to here. So rewriting the models in Azure ML supported frameworks. Azure ML supports popular machine learning frameworks like TensorFlow, PyTorch, and scikit-learn. You can rewrite your NumPy models using these frameworks to leverage Azure ML's functionality. It means if you give it to TensorFlow or PyTorch, there are conversion setup that converts into Azure ML compatibility basically. NumPy directly it cannot be ported into ML supported frameworks. You need to depend on these tools. Okay.
Okay.
Right. Now converter tools. Azure ML provides converter tools that can help convert model trained in certain frameworks like TensorFlow, ONNX, and scikit-learn to a format that is compatible with Azure ML. Yes, these tools can be useful converting ML model, NumPy models to a format usable with Azure ML. This is the one we need to understand it when you talk about the NumPy migration into Azure machine learning. Okay. So ONNX support is what if your NumPy models can be exported to the open neutral network exchange. ONNX full form is Open Neutral Network Exchange format. You can directly import these models into Azure ML. ONNX allows for interoperability between different frameworks, make it easier to migrate models between platforms. So what is the platform? NumPy, it should go to ONNX. and when next need to convert into ML models. It means model conversion is required. Now you see, you have a virtual machine of Oracle VirtualBox, or you can have VMware VirtualBox or Microsoft Hypervisor VirtualBox in your laptop. You are running. Assume that. Now those virtual machines you need to migrate as on-premises to cloud migration. When you migrate the virtual machines, any cloud services need in a standard format, which is called OVA format.
Mhm.
Okay, you have a converters to convert into that format. Then after doing conversion, then you can upload into AWS or Azure as an image, as a private image. Then that private image can be reused by our cloud projects resources to deploy that as mission with the same setup. Let us say you have used extensively Jenkins and a lot of other tools, okay, in that mission, Linux mission.
Mhm.
One VMware mission is there. Now you need to use the same setup. That is the standard you want to give it your project resources as cloud expert. Now, what you are supposed to do, you need to convert into OVA format. That OVA format need to be uploaded into image model image service. Then in the image, you can declare that as first prioritized image for particular stream of the resources in the project. Then they'll use that. They'll deploy in their cloud setup. Then after that, they'll use other VMs also, either Azure or AWS VMs locally in the cloud platform. The same way here, when you migrate NumPy models, we need into one format.
Mhm.
That format is available. If it is available, then it can be transformed into ML models.
Mhm.
That is the thumb rule here. It is just like a native cloud, private cloud migration to public cloud.
Mhm.
Okay, then custom integration. Depending on the complexity of NumPy based models, it may be possible to create a custom integration within the Azure ML to support these models. This approach may involve writing custom code to load and execute NumPy models within the Azure ML environment. It means we need to see the uh, gaps here and what are the action steps you need to take it, and you need to prepare a kind of checkpoints also, checklist also, whether you process it that before completion of the task. In every project, normally it is better to have a checklist, and compliance need to be verified it. After that, it need to be approved it to release that model, okay, for
Yeah.
testing or any live also. It is just like software testing model, how you do it, okay. Consult Azure ML documentation and support. Azure ML documentation and support resources can provide guidance on the best practices for migrating and integrating custom models into Azure ML platform. Consulting these resources can help in determining the most suitable approach for your specific use case. Basically, in the documentation, they have given how these models can be converted from NumPy to Azure ML via different tools. Okay, that solution need to be identified for your need. By exploring these options and considering the nature of NumPy-based machine learning models, you can effectively convert and integrate these models into Azure machine learning for seamless deployment and management within the Azure cloud ecosystem. So where we are in the Azure machine learning platform.
Yeah.
From where we traveled it from NumPy models to Azure cloud services, basic Azure cloud services. Then from basic Azure cloud services to ML services. Why we need basic cloud services? Because to process the data, we need a cloud service. That is the reason we were dependent on the cloud services. Then later on, we thought, let us convert into Azure ML models. Then we transformed them into Azure ML models by using different techniques and process. Okay. Now, generative AI has come to market. When generative AI has come, still cost-effective solutions can be provided to the stakeholders. because we need to save the budget as an IT expert. Because
Mm.
everywhere in the past 25 years back, if you see, infrastructure cost was major comparatively with our salaries also earlier. Now it became very cheaper, but salaries are higher. Our salaries,
Mhm.
IT professional salaries, comparatively with the cloud budget, monthly cloud budget
Mhm.
for managing the systems, because these technology learners are less, and working with multi-skilled approach, it is very less with the resources. So whoever has got multi-skilled approach, they are capable of doing means they'll pay more perks and hire them and use them, that's all. Okay, that is
Mhm.
also another budget. One need to configure it as cloud solution expert. Who are all the resources required? It we planned in the e-commerce platform, right? How when we move to cloud, what are the resources required? Human resources and cloud resources, right? The same way, you need to plan each stage wise the required resources also while doing the solution demos.
Mhm.
You're getting?
Yeah.
I showed you with e-commerce, right? We discussed about traditional setup in e-commerce. Then later we moved to Azure cloud services. Then later Azure generative AI conversion, we planned it, right? The same way.
Mhm.
So let us come back to the generative AI conversions. When
Mhm.
migrating Azure machine learning NumPy models into Gen AI, are several options available to facilitate this transition. Here are some approaches. First one is rewriting the models in AZ Gen AI compatible frameworks. It means here also compatibility is required because we were there with the NumPy only so far on the top during ML
Okay.
conversion also. So here what happens? AZ generative AI may have compatibility with popular machine learning frameworks like TensorFlow, PyTorch, or ONNX. Rewriting your NumPy models using these supported frameworks can ensure seamless integration. Let us say here they're talking about directly taking the NumPy models into generative AI. It is not like we are traveling from Azure ML to this one, not like that. The conversion of the Azure ML models into generative AI is a totally different process, migration process. But here we are
Mhm.
working with NumPy only still. Assuming that NumPy models are not yet converted into Azure models, Azure ML models. That way, this is the proposal, rewriting models into generative AI compatible frameworks. Okay, then utilizing ONNX platform. This is also same thing. These models can be exported to the open neural network exchange format. You can leverage this standard to migrate your models to Gen AI. So ONNX provides interoperability across different frameworks and platforms, make it a viable option for migration. Yes, I mean, same thing it is giving here. Okay, but retraining, how it happens, retraining in aged Gen AI, depending on the complexity of your models and the specific algorithms used, retraining your NumPy models with Gen AI using its native tools and services can be an effective approach. This allows you to take advantage of unique capabilities of Gen AI. It means Gen AI has got models. We saw form recognizer, we saw translator, we
Mhm.
saw speech therapy,
Mhm.
then personalization also is available. Marketing purpose, right? So if you take some of the models from NumPy, assume that you have a personalization marketing.
Mhm.
Then that NumPy model will be attached to this particular service. Azure Gen
Mhm.
AI personalization is there, right? There is a
Yeah.
service for that, right? So
Yeah.
you need to understand generative AI services in depth also at the same time. NumPy model is used for which function of the ML. That ML function need to be mapped to the generative AI services. Then you need to migrate it after conversion of the code
Mhm.
into the required format or something like that. Okay, right. Then converter tools. Agent Gen AI may provide specific converter tools or support for converting models from AZML to AZ generative AI. It means if it is already existing the model
Mhm.
AZML, this is the solution. Earlier solution was if it is existing already with a NumPy, yes, this is the one. In generic, you need to convert into format and upload that into generative AI also. It means generative AI has got multiple options to convert NumPy models. Okay. Then in the converter tool, how it is, AZ Gen AI may provide specific converter tools or support for converting models from AZML to AZ generative AI. These tools can assist converting your NumPy models to a format compatible with generative AI while preserving the model's performance. See, we need to see here if legacy systems are developed from NumPy,
Mm.
they need to continue with the NumPy setup only because they don't want to change the models with the trained models. They want to customize the models but continue the models with that. If you want to continue the models, generative AI has got that support also with interfacing with the NumPy models. That is the
Mm.
one here conversion tools are going to help. Then
So
custom
is
integration.
right. So
Yeah,
is it that some of these models are available? So we need to see if there are any examples of some of the NumPy models that are already converted into Gen AI. For example, if there are any models that are already converted into Gen AI.
yeah, they will be available on internet. Obviously,
Okay.
you need to search for through ChatGPT or something.
Hmm. Okay.
Okay, that is the generic solution, right? You have AI tools in your fingertips. You write the prompt, you will get the solution in minutes, right? So next one is consulting agent Gen AI documentation is common here also. That is the way it is done. So by exploring these options, considering the specific of your NumPy models and capability of generative AI, you can successfully migrate your models to AZ generative AI while ensuring optimal performance and functionality within the new platform. So that's where we completed. We traveled from to learn what is NumPy in
Mhm.
relevancy to the ML machine learning models and how NumPy models can be applied it in machine learning in traditional way. Then how NumPy can be connected to the Azure cloud services to process the data, maintain the data. At the same time, we also discussed about the how NumPy libraries can be connected to the Azure machine learning while migrating. What are the steps need to be followed? Then after that, how generative AIs can be implemented for NumPy libraries directly or through Azure ML process also, right? So these are the
Mm.
ways for migration steps. One need to understand it and plan accordingly the projects. There are multiple ways you can convert these things. Is it
Mm.
clear for you?
Yeah.
When you are giving your demos, solution demos, you have to take one of these only. You should not think multiple ways. You take one practice, then from that practice you start doing the solution demos. Okay,
Mm.
right, I'll stop recording.